Question number 35. From any point P are drawn PM and PN perpendicular to ZX and XY planes. O is the origin and alpha, beta, gamma and delta are the angles which OP makes with the coordinate planes and with the planes OM, N. Prove that if the coordinate of the point P are ABC, the equation of the plane OMN is x by A minus y by B minus z by C is equal to 0. Second, delta is equal to sine inverse ABC by root of A square plus B square plus C square into B square root of B square C square plus C square A square plus A square B square. And third, cosec square delta is equal to cosec square alpha plus cosec square beta plus cosec square gamma. It's a very lengthy question. So we will start with what is given. So point P, coordinate of point P is ABC, and PM and PN are perpendicular to ZX and XY planes. Let's start with that info. We have like this X, Y. So it is given that PM and PN are perpendicular to ZX and XY planes. So say ABC somewhere like this. A point in space, 3 dimensional. And now see a PM is drawn perpendicular to ZX plane. So ZX, let's drop a perpendicular like this. So ZX plane, and M is the perpendicular drawn. So this PM is the perpendicular drawn to ZX plane. And N is drawn perpendicular to XY plane. Here draw. So PM and PN are perpendiculars. Now O is the origin. So we need to find first the points M and N. M and N are just foot of perpendicular from P to the plane. So since it is perpendicular, we can easily say that since M is perpendicular to ZX plane, PB, ABC. So from the figure itself, we can see that implies M is what? A, and the Y component is 0. A, 0, right? You drop a perpendicular like this, A and C won't change. X and Y coordinate, X and Z coordinate won't change, and Y coordinate becomes 0. Similarly, if you see, you drop a perpendicular like this to XY plane, Z component will become 0 and N will be A, B, 0. We got our M and N, that M is A, 0, B perpendicular to, that implies A comma B comma 0. So we got our A, M and N. Now we need to construct the equation of the plane, OMN. So we know equation of a plane passing through origin and these 2 points. General equation of a plane passing through origin will be something like ax plus by plus cz is equal to 0. Now we know that this plane passed through A0C. So from that we can write since A0C, the D component is 0 because it passed through origin. T means the constant term. The constant term is 0 here because it passed through origin. Now AOC lies in 1. Therefore, we have A into A plus 0, that is C, into C is equal to 0. That therefore we have A by minus, one sign will be negative, so we can write minus C to C by, we will use this later, so let's mark this equation 2. Now A B 0 lies in equation 1. We have A into A plus B into B equal to 0. That gives, you take A by minus B is equal to B by, you take B by A. So this is equation 3. Now if you compare, we know that A by minus C. So from this we can write A by, if you, for comparison, to make both sides same, multiply both sides with B. These sides B, we have BC equal to C by AB. And here if you multiply throughout by C, and here 3 by is A by minus BC equal to B by AC. Now you can just come from these or this 4 and 5. 4 and 5 gives A by minus BC is equal to B by AC is equal to C by. So now we have the direction ratios ABC, which is which defines this plane. So 1 becomes minus BC into X. Sorry, minus BC to X plus AC into AC into plus AB to Z equal to. Now this is the required equation of the plane. We will call it 6. Or we could throughout divide with dividing by this. Dividing by ABC, we have X by minus ABC. We will divide with minus ABC. The reason being, sorry, being have positive negative term in the X component. The required solution, we have X by A as the positive. X by A minus Y by B plus minus Z by C equal to 0. Required equation. Required. So we proved the first part. First part is showing that equation of the plane OMN is x by a minus y by b minus z by c. So that part is done. Now let's move on to the second part. Here we have to find the angle delta. So delta is nothing but angle OP makes with the coordinate plane. Let's see OP. So OP is this line. So we need to find the angle delta. O is the origin, and alpha, beta, gamma, and delta are the angles which OP makes with the. There are coordinate planes and with the planes OMN. So alpha, beta, gamma are the angles OP makes with coordinate planes, and delta is the angle OP makes with the plane OMN. So if you see OMN, you draw it will be really difficult to draw here. We'll just try. So OMN, sorry, OMN is this plane. OP is making some angle with this plane. We have to find that. For that, what we are going to do is we will draw a perpendicular like this. So angle this normal to this plane makes with OP complement of this angle. Say this is, so angle we are looking for is this angle, this line makes with plane. So we can say that this angle, the angle this line makes with the normal to the plane is 90 minus delta. We will find this 90 minus delta, and from this we can take delta. What we have done is drawn a perpendicular to the plane OMN, and then we calculated the angle this normal makes with the line segment OP. So we'll do that now. Second part. So normal, we have already a direction ratio of the normal to the plane. Normal to the plane OMN is we have already got that it is 1 by a minus 1 c. From this equation we can write the direction ratios of normal as 1 by a minus 1 by b and minus 1 by c. Now direction ratio of line, we need OP, direction ratio of line OP. Since P is ABC and O is origin, we can say that direction ratio is A comma B comma C. So this is the direction ratio of OP. From this we can find the angle cos using the concept cos theta equal to A1 A2 plus B1 B2 plus C1 C2. So cos of angle is, as I said earlier, it is cos 90 minus delta equal to 1 by A into A plus minus 1 by B into B plus minus 1 by C into I. Since we have direction ratios here, we have to convert it to direction cosines. For that we divide with 1 by A square plus 1 by B square plus 1 by C square into A square plus B square plus C square. So if you simplify, we get this as 1 cancels minus 1. Here we get minus 1 by root of 1 by we'll do one thing, we'll take the LCM, get B square C square A square B square the LCM. If you a square b square c square is the LCM, so b square c square plus a square c square plus a square b square by so by root, since there is root, we have abc of a square. So abc goes to the top. Just cut this and write in on the top. What is cos 90 minus theta? It is sine of delta. Cos 90 minus theta is sine of delta. From this we can say that delta is from also we can ignore the negative since we are only taking the acute angle. 90 minus theta will be an acute angle, so we can ignore the negative sign here. We it will be the same, theta will be same, so ignoring that we can take delta is equal to sine inverse ABC by root of b square c square plus a square c square plus a square b square plus. Just check. This is what we need to prove the second. So that is also proved. So second part is also over. Now third part, let me just go through. Let me see. Third part is connection between delta and alpha, beta and gamma. So alpha, beta, we need to find what alpha, beta and gamma. If you see the question, alpha, beta, gamma are the angles which OP makes with the coordinate planes. So we have to write alpha, beta, gamma. From this OP too complicated. We'll either draw a new diagram or just imagine what is happening. We have a line like each OP is making different angles with these coordinate planes. So suppose one example is OP alpha angle OP makes with the coordinate plane x is equal to 0, then this angle, just give it a color. Coordinate plane x is equal to 0 means this plane, even this is the x-axis. So it's this angle. This is the alpha angle. So angle OP makes with. Instead of that, what we will do is we will find the angle between OP and the normal to the x is equal to 0 plane. Normal to the x is equal to 0 plane is this line. This is normal. So if you take this, this will be 90 minus alpha. So angle OP makes with the normal to this x is equal to 0 plane. That will be 90 minus alpha. So we will find that. We already know the direction ratios of OP. dr of OP is 1 by A minus 1 by B minus 1 by C. By A minus 1 by B minus 1. We have that. Now direction ratio of normal, dr of normal to x is equal to 0 plane is direction ratio of this x-axis, which is 1 0 0. So we can say cos, similarly this angle, the angle between these two, 90 minus alpha, cos 90 minus alpha is equal to 1 by a into 1, 1 by a plus minus 1 by into 0, minus 1 by b into 0 plus minus 1 by c into 0 by root of 1 by a square plus 1 by b square plus 1 by c square into root of 1 square plus 0, 0. So this is nothing but this two terms cancels, 1 by a. We can write, if you take LCM, again we get ABC by root of, here there is a 1 by a, so 1 by a into ABC by root of b square c square plus LCM, taking LCM, b square c square, here a square c square by a square b square c square becomes ABC, and into root of 1, so that will become 1. So this, and a cancels, in ignoring the negative. Okay, there's negative signs here, sorry. So this becomes cos 90 minus alpha is sin alpha. Sin alpha becomes BC by root of b square c square plus a square c plus. Now, if sin alpha is this, we can say that that implies cosec square alpha, that is inverse square. Cosec square alpha is what? B square c plus a square c plus a square b by. So I made a mistake here, sorry. Direction ratio of OP was ABC. I took the direction ratio of the normal to the plane as direction ratio OP. So this entire thing is, sorry for wasting your time. Just correct it. So cos of 90 minus alpha becomes a into 1 plus b into 0 plus by of square plus square plus square square plus 0. That becomes sin alpha is equal to a by root of a square plus b square plus c square, or 6 square alpha equal to a square plus b square plus c square by, now a square, sorry, a square. Now we got our cosec square alpha. Now since going to be symmetrical, we can write similarly cosec square beta will be what? You see, this is a symmetrical equation. We can say a square plus b square plus c square by b square, and cosec square alpha gamma will be a square plus b square plus c square by c. So we got our cosec square alpha, beta and gamma. We will call this equation or 8 or 9 and this 10. So now using eight And then we can say that cosec square alpha plus cosec square beta plus cosec square gamma equal to add all these s square plus square is common. Now what is this? You take LCM a square plus this is from 7, as you can see. Final will not be using. So from this we can see that this is the cosec square delta we need. So from 7, so this is the required equation. So third one, cosec square alpha plus beta plus gamma. So we proved that also. This is the 3 proofs. So it's quite lengthy question. So these are the steps. I hope clear. There is any doubt, sorry for making the mistake here. So if you instead of I just wrote direction ratio of OP as this one. So such simple mistakes can completely mess up the solution. Be cautious writing lengthy answers. Yeah, so these are the steps. If you have any doubt, do comment. Solution to question 35. Thank you.